Hopefully the next one after this one will be a little easier. Now well, this is just getting complicated stuff. Let's erase something. Now the next integral, the next case is with a branch point. It's essentially the same. We have adding a log x, right? And yeah, adding this, obviously, you introduce a branch point at the origin. This is a branch point. But as long as you cut the complex plane somewhere, and then you just integrate over the part that is single value, then everything is fine, everything back to normal. Okay, and so therefore you can cut anywhere, and we can keep using this loop because we analyze the integral. Adding a log x doesn't change the fact that over the large arc is still zero because a log r when z goes to infinity, log z is the magnitude is just log r, but the denominator is one of the denominator r cubed, so the whole integral is still going to zero along the arc. Okay, so nothing changed that much except that going back to the I sub one, right? Because now you need to consider one more thing. Yeah, right? Because you have a log x, a log, or this is along this line, right? So log z becomes a log r plus pi 2 pi z. That's extra factor. Okay. So everything the same. You still need to evaluate whether the residue will be slightly more complicated now, even than before. But now is this I sub one is a little problematic now. So now you have the log r by 2 pi plus 3, right? Log c, and then you don't forget the dz. Dz has e to the I by 2 pi plus 3. That's phase is still here, right? And so there are two terms, right? The first term is this is infinity to infinity, so it's introduce a minus sign to go back to here. So the first one is the same e to the I 2 pi plus 3 times I is redefined as this one, which is the first term. And then the second term is you have this extra factor, so plus actually minus minus 2 pi I over 3 times e to the 2 I times 2 pi over 3 times the integral that we had before times, because now you don't have the log for this for the second one, which is just the integral we had before, which is just this one, 2 pi. Right. So, this combined with that, I sub one combined with I, this one, and then minus 2 pi I over 3 2 pi I over 3 times the integral that we did in the last example, and that equals to the residue. Now the residue is still at this point, pi over 3 at the unit circle. Okay. And no, it's just the same. It's just need to evaluate that. Right. I probably won't go through everything now because we know how to do it, except that you're just adding one more term, log of e to the I. Just finally evaluate at this one, e to the I minus. And the other two is just like what we did before. One is c plus one, which is e to the I plus one. The other is e to the I pi 3 minus e to the minus I 3. Right? Because we still have the same pole here, here, here. So the three factor. This is from this root. This is from the root of the complex conjugate of this one. Okay. And now you need to figure that out and subtract and lots of algebra. Right. But no, I don't want to struggle with that here because I spend too much time. Okay. It's okay. So that supposedly the at least I checked whether I get this is 11.112, right? So minus this one, but minus this one minus 2 pi r over 3, 2 pi over 3 equals 2 pi r. Now that one need to I haven't re-evaluated, but you now you need to figure the other one. Okay, just